In this module, we'll be talking about chapter 9, which begins with oxidation and reduction. The overall chapter is looking at redox chemistry in general. So oxidation and reduction can be defined in many ways, such as oxidation being the loss of hydrogen or the gain of oxygen, and reduction being the gain of hydrogen or the loss of oxygen. It can also be looked at from the perspective of electrons. So let's first cover the aspects of hydrogen and oxygen. So oxidation is the loss of hydrogen. So the amount of hydrogen would go down, whereas reduction involves an increase in the amount of hydrogen. Whereas it's the inverse when we look at oxygen. Naturally, when it's oxidized, the amount of oxygen available is increased, and when it is reduced, the amount of oxygen reduces. Next, this can be when oxygen has been added or hydrogen has been added. It can be symbolized by this. So this means that oxygen has been added, and therefore it's an oxidation reaction. Then this symbol symbolizes that hydrogen has been added, and therefore it must be a reduction reaction. Okay, next we'll be looking at how this relates in terms of electrons. So oxidation is essentially the loss of electrons, whereas reduction is the gain of electrons. A helpful mnemonic that one can use to remember this key phenomenon is oil rig. So oxidation is loss, whereas reduction is gain. This is extremely crucial and one that we need to remember in order to fully understand and comprehend redox chemistry. So let's look at an equation and how oxidation and reduction is relevant in this case. So we have zinc in solid form plus copper 2 plus, and this is an electrolyte, so it is in aqueous form, produces zinc 2 plus in aqueous form plus copper in solid form. So in this case, we know based on the atomic charges, based on the charges of each individual constituent, we can work out the changes in oxidation and whether it is indeed an oxidation and reduction reaction. So in this case, because zinc is the sole element, it has an oxidation number of 0. Here, copper is also the sole element. However, it is stated explicitly that there is a charge of +2, therefore the charge is +2. Here is the same as copper in the reactant side. So zinc has a charge of +2, and copper now is as a single element has a charge of 0. So using this information, we can create something called half equations, which we can use to determine which side is oxidized and which side is reduced. So first, let's look at the half equation for zinc. Zinc gives Zn 2 plus aqueous. So we see here that the charge has increased from 0 to +2, and therefore in order to make the overall charge equal, we'll have to add 2 electrons on this side. And we know that since it's been gained on the product side, it's also been lost on the reactant side. Therefore, it has been oxidized. Next, we'll be looking at the copper side of things. So we have Cu2 plus in aqueous, which means that it's soluble in water, and this gives Cu as a solid. So we have +2 on the reactant side and 0 on this side. Therefore, the left-hand side must decrease by 2 units of charge in order to become to have a neutral charge of 0. So therefore we can add 2 electrons on the left hand side to balance out the entire equation. And looking back at our notes, we know that reduction is a gain of electrons, and here, as the copper 2 plus has gained 2 electrons, it's been reduced. So these are the half equations. And it shows that this overall reaction is indeed a redox reaction, as it includes an oxidation and it also includes reduction.